Hi guys, this is my first YouTube video, so I'm here with my snuggle buddy, Miss Bunnywiggles. I don't know how I came up with that name, but I was like 7, and I was just like, let's name me Miss Bunnywiggles. Also, comment below in the chat if you also have interesting stuffy names. But anyways, she's going to be helping us solve the last 5 problems of almost every AMC8 exam. So let's get started with the year 2025, which, by the way, is a perfect square, which is 45 squared, I think. And speaking about interesting facts, at the end of each of my videos, I'm also going to add an interesting math fact. So stay tuned. So let's get started.
Okay, so for problem 21, the problem says that the Connors Square School has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. The school noticed that each pair of connected pods has been assigned to grades differing by 2 or more grade levels. For example, grades 1 and 2 will not be assigned in pods directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F? Okay, so thankfully for this problem, I made a little diagram. If I can find, oopsies, if I can find it. Oh, right here. Yeah, I made a little diagram for it. So as you can see, the circles are the pods, and the lines are just like the walkways. And I also label C, E, and F. So first, you have to find the pod that has the most walkways, and in that case, it would be pod C and pod F, because they both have 5 walkways connecting to 5 pods. So that means that they have to receive the edge grades, aka 7 and 1, because C only has one pod that isn't connecting to it. And F also only has one pod that's not connecting to it. So let's put a 7 over here, and let's put a 1 over here. And this is the only pod that does not connect to C. So over here, you have to put a 6. And similar for pod number 1, this is the pod that does not connect to pod number F. So this has to be 2. Okay, so now let's focus on this pod right here. We have 3 choices, 3, 4, and 5. If you try 5, that wouldn't work because there's a 6 over here. 4 also wouldn't work because 3 and 5 would go here, and that just doesn't work. So then that means that 3 has to go right here. And then since 4 doesn't work for this one, then 5 has to go here. That leaves one more choice for E. That means E has to be 4. And if you check it, you will find that that is correct. So you just have to do 7 plus 4 plus 1 equals 12. So the answer is A. Right. So now that we figured out problem 21, let's move on to problem 22. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? After you read this, you automatically realize that the first hook and the last hook have to be empty because there are the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. So if there is no hooks before the first coat and there are no hooks after the last coat, that means that there are no coats between every coat, and that just doesn't fill the requirements. So then um you also know now that your first coat has to be hung on hook number 2. So that means the next one is hung on hook number 4. Next one is 6. And then go on and on until you do 35 minus 1 is 34. So that means 34, hook number 34 is your last hook that you hang a coat on. And you know that this works because 34 is a multiple of 2. So this works. Okay, so after you're done with this, let's move on to the next one. Let's try if there are 2 empty coats before the first coat, that means that your first coat is hung on hook number 3. And the next one is 6, next one is 9, dot, dot, dot. The last one is 35 minus 2, that's 33. You also know that this works because 33 is a multiple of 3. So now you realize that 2 plus 1 equals 3, and then 34 minus 1 equals 33. So with this knowledge, you can apply it to the rest of the pattern. So 3 plus 1, that's 4, You don't have to care about the middle numbers because they don't really matter. Dot, dot, dot. 33 minus 1, that's 32. You also know that this works because 32 is a multiple of 4. Okay, next one. Now you have 5, dot, 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 31. This does not work because 31 is not a multiple of 5. 6, dot, 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 30. You know that this works because, well, 30 is a multiple of 6. And the next one is 7, dot, 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 29. Does not work. And then since it's going to take a long time for me to list everything, I made another list down here with the entire thing. So as you can tell, there are 1, 2, 3, 4, 5, 6, 7 scenarios that can work in this. Let me say answer is D. Congratulations, you have solved problem 22. More torture. Let's do problem 23 now. Okay. How many four-digit numbers have all three of the following properties? Number one, the tens digit and the ones digit are both 9. So this knowledge, you can just do this, because it's four-digit numbers, and then that's 2 digits and 9 and 9. The number is 1 less than a perfect square. So that means that if it's 1 less than a perfect square, it has to end in 0, 0. The number is a product of exactly 2 prime numbers. I think that the third one is the hardest to do right now. So to get a perfect square to have 0 and 0, just think of all the 2-digit perfect squares and add 2 zeros at the end, you know? Let's see, this is what I mean. So 4 times 4 is 16, add 16 here, and then 5 times 5 is 25, 0, 0, and then 36, 0, 0, 49, 0, 0, 64, 0, 0, 81, 0, 0. And don't forget the last one, 1, 0, 0, 0, 0. Because 1, 0, 0, 0, 1, 0, 0, 0, 0 minus 1 is what 9, 9, 9, 9. But actually that one doesn't work because it's divisible by 9, and 9 is already 3 times 3, which is the product of 2 primes. So that just already doesn't work. And also this one doesn't work either because this minus 1 is 6, 3, 99. So that means that this is also divisible by 9, which also doesn't work. So just cross out that one. The rest of the numbers are basically just like this is the square minus 1 squared. So if any of this rings a bell, then this turns into a squared minus b squared, which if some are familiar with, this is also equal to a minus b times a plus b. And then if you plug in the numbers from here to here, then you get 40 minus 1 times 40 plus 1, which is 39 times 41. You know 41 is a prime, so that passes, except 39 is not a prime. This is 3 times 13. So that means that it's not the product of 2 prime numbers, so this is not correct. Using the same knowledge from 1600, then this is 50 squared minus 1 squared, which turns into 51 times 49. You already know that 49 is not a prime number, so this is also not correct. 51 is also not a prime number either because it's divisible by 3. Okay, next one, 36. This is 60 squared minus 1 squared, will equal to 61 times 59. This is actually 2 prime numbers, so I'm just gonna circle that. And then this one is 70 squared minus 1 squared, which is 69 times 71. 69, I already know, is not a prime number, so this is also not correct. And then the last one is 90 squared minus 1 squared, which is 91 times 89. 91 might be tricky, but it's 7 times 13, so 91 is not a prime. If you like learn the rhyme, 91 is not a prime. This one tricks me every time. So that one also doesn't work. So that means that there's only one four-digit number that fulfills all of the three following properties. So that means the answer is B. Okay. Now let's continue to the second to last problem, problem 24. In a trapezoid ABCD, angles B and C measure 60 degrees, and A and B equal D and C. The side lengths are all positive integers, and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all of these conditions? So I'm just gonna redraw this trapezoid right here. So this is a straight line. This is also a straight line. Ooh, oopsies. Straight line. And then they have these guys, and this is A, B, C, and D. This is 60. This is also 60. So if these are perpendicular, right triangle. And if this is a right triangle, then you know that a quadrilateral has to have 360 degrees in its entire angles, minus 120, because of these two right here, is 240. 240 divided by 2 is 120. So that means each of these big angles is 120. That means D equals 120 and A equals 120 also. So if this is 120, and you know that these are all right triangles, that means that 120 minus 90 is 30. So this right here is 30. So now you have a 90, now you have a 90, 30, 60 triangle. And if it's a 90, 30, 60 triangle, and this is 90, this is 30, this is 60. Wait, this is 30. Oops. And this is 60. Then that means that this is 1, 2, 2, square root of 3. And since this and this are equal, let's name this one x, and also let's name this one x too. Like also x, not x2. So then if this is x, then that means that this is x over 2. And this is also x over 2. And since that these two are also equal, let's name them A and A. And since the perimeter is 30 units, let's do x plus x plus x over 2 plus x over 2 plus a equals 30. This simplifies into 3x plus 2a equals 30. Okay, so with this, now you can tell that you just have to plug in some numbers. But if you want to plug in for A has to be a multiple of 3, and similarly, x has to be a multiple of 2. Because there's a 2 over here and there's a 3 over here. So just have to like swap it kind of. So if you try to list, then let's make a chart first. And let's make this x. So if A is using this equation, let's say actually x is 2. That means A has to be 30 minus 6 equals 24, and then 24 divided by 2 is 12. And then continue the pattern. Let's make this 4 now. That means that 3 times 4 is 12. 30 minus 12 is 18. 18 divided by 2 is 9. And now you realize this is minus 3, and this is plus 2. Let's continue the pattern. This is 6 minus 3, and that's also 6. And then plus 2, this is 8, and that's a 3. And you know that there are only 4 because you can't have 0 as 1 because a trapezoid cannot have a side length of 0. So that means that your answer is 4, which is E. So finally, let's now move to problem 25. Michaela finds all the possible ways to draw a path in a 5x5 diamond-shaped grid. Each path starts at the bottom of the grid and ends up at the top, always moving 1 unit northeast or northwest. She computes the area of the region between each path and the right side of the grid. 2 examples are shown in the figure below. What is the sum of the areas determined by all possible paths? Okay, so you find this problem by counting the number of pairs and then times 25, which is actually the entire number of paths. So, oops, second, paths divided by 2, you need times 25, which is equal to your answer. I'm just going to leave this here for now. So what I mean by pairs and why I divide it by 2 is because let's take this figure for example. Its inverse, or what I call pair, would be this guy right here. Because if you flip this figure by 180 degrees, it'll turn something like this. So this is the square, and then this would be the path. And then since the right side is always shaded, then this part would be shading right here. So if you add these two up together, then this would equal to 25. So you just have to find the number of pairs and then you times 25. And that's the total number of, well, basically some areas determined by all the possible paths. So to start doing this, you have to find the total number of paths. And to do this, you have to find the number of blocks that Michaela travels from the bottom point to the top point, which she travels 10 blocks, 5 northwest and 5 southwest. All right, so with this information in mind, we have to do 10, pick 5, because if you pick 5 of the blocks that she travels to be, let's say, northwest, then the other 5 blocks that she travels will automatically be southwest. So, sorry, northeast. Oopsies, will be northeast. All right, so 10 pick 5 is 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2. And if you do some canceling, it will look something like this, which is 36 times 7, which is equal to 252. And since this is the total number of paths, you have to do 252 divided by 2 times 25, which is 126 times 25, which is 3,150. And if you look at your answer choices, this would be B.